Hey there. So today I'll be explaining on how you can actually scale your OpenClaw from small agents to big agents. So there are three processes to do. You can do either by horizontal scaling or vertical scaling or concurrency request. So today I'll basically show you how you can do this by concurrency request. So let me open my terminal here, and as we can see we have run the command of time sequencing for 20 requests here. Okay, so what this basically does is that whenever you pass this request to the terminal, so this actually basically does your concurrency request on scaling the OpenClaw for bigger workflows. Okay, so it processes multiple messages in parallel using the shell jobs. Okay, actually yes, it represents a real workflow scaling. It's a concurrent invocation, and let's see what time it takes to actually does that. Let's come down, and it has taken around 4 minutes and 0.972 seconds. Okay, so what I'm basically going to do is that I want to reduce this time for execution. Okay, if I want to reduce the time for execution here, so basically what we need to do, we need to add some parameter in order to reduce this, right? So how we can add a parameter to reduce this? Basically we want to run two commands parallelly. Okay, so whenever we want to run two commands parallelly, and if we want maximum processes only for two. Okay, so for two parallel processes we are running this. Okay, so we want from sequence 1 to 4 two parallel processes to run. And what does this I means? So basically this I means that whenever you run the processes in parallel, it acts as a placeholder and replaces it with each input value. So we are telling our exarchs that whenever we see this command, this curly braces, we substitute the correct input value there. So this is number one, number two, number three, and all. So see, it has generated me topic one. Okay. Then let's scroll down. Topic two, topic three, topic four. Okay, so how long it has taken me? See, it has taken me around 3 minutes and 10 seconds when I am running commands parallelly with two processes per second. So what does it mean? Whenever we are running one process in parallel, it's taking some amount of time. And if we are running two parallel processes, it's taking less time, right? So what is it? What does it mean here? Okay, so this is about parallelism and sequential execution. So whenever a task takes a certain amount of time, a process, whenever it runs in sequential, it takes more total time. But whenever you run two processes at once, your parallel time gets reduced because your task runs simultaneously instead of sequentially. Okay, so that's why mathematically you can calculate the total time as number of tasks divided by your each processing time into time taken per task. So P is number of parallel processes. Okay, so you can do this similarly whenever you want to run any request here. Okay, as we can see here, you can do this similarly for all the parallel and concurrent requests. Okay, and there is even another way to do scaling. How you can do, you can create separate agents for this. Okay, so if you want to create separate agents for scaling, let's say you want to you want to create planner agent, execution agent, you want to create a multi-agent architecture. So you can create like workers agent, worker 1 to 5. So you have 5 independent agents and each agent maintains its own context. Okay, so you can check each agent's configuration, whichever it uses Gemini 2.5 Flash, and why it is better than single agent, because you may get context locking, serialized internal execution, and slow scaling. So expected time after your DNS fix becomes for first parallel process 40 seconds. If you want to use 5 parallel processes, it will only take 8 to 10 seconds. But if you still get like 30 plus seconds for P5, we are hitting the API rate limit. Since in WSL, we are basically having an API rate limit, so we need to ensure that whatever the processes are running here, we have to cancel it after a certain period of time in the execution term. So for example, I have cancelled this here. Okay, so you can get the total time taken for the processes to run here. But as we can see, whenever we are running parallel processes, it's taking less time for execution compared to a normal single execution process. So that basically means that whenever you want to run for parallel, So whenever we want to run for parallel process one, this is the command. Okay. And whenever you want to run any two parallel processes, let's come down. So this is the command whenever you want to run two parallel processes, okay? And you can measure the time here. Since Gemini takes a lot of time, you can measure it for 20 parallel processes as well. But it takes a lot of time, so I'm not running it here. So you can check this accordingly as well, okay? And you can send a simple request to see how long it takes. It's taking 43 seconds. It's taking 3 minutes, 10 seconds. So that basically means that if you, whenever you want a production level scaling, we need to prevent API flooding, control the burst rate, and improve the stability. Okay, so in this, we can try using load testing, multi-user simulation, or workflow through improvement. In this way, we can improve our scaling more efficiently. Okay, so that's all from my side. Thank you.